All right, so lastly we left off critical numbers. We know are numbers where the derivative is 0 or undefined. You knew it would come back to derivatives again. That's why we learned them. So we're going to do an example on finding extrema over an interval. And here are the steps to finding an extrema on the interval. So there's 3 steps. The first step is to find any critical numbers. Using f prime of x. Okay, the next step is make a table of values with x values of endpoints and critical numbers. Okay, and then you plug in your x's and identify the highest and lowest y values. The highest ones are your maxes, the lowest ones are your mins. Pretty easy. So you just got to check critical numbers and endpoints. And you can have more than one max, you can have more than one min. So that's okay if they reach the exact same height. So here's an example that's like your worksheet. If I said f of x is 2x minus 3x to the 2/3. And it goes over the interval -1 to 3. Okay, so this would be a weird looking graph. You can graph it on your calculator just for fun. And we'll take a look at it at the end. Alright, so first thing we want to do is find any critical numbers, which means we need the derivative to be 0 undefined. So I'm going to find the derivative first. Derivative of 2x is 2. Derivative of this, -2/3 times 3 is -2x to the -1/3. No ninja rule needed because they're x's and we're taking a derivative with respect to x. So I want to know on this one, I want to know 2 things. When does f prime of x equal 0? And when is f prime of x undefined? Okay, sometimes you'll have one and not the other. Sometimes you'll have both. I gave you an example where you actually have both. So I'm going to set this thing equal to 0. It might be beneficial if I rewrote the original equation. F prime of x equals 2 minus, now this negative exponent would take the x to the 1/3 to the bottom. That might be helpful. Okay, so 1 I'm going to set it equal to 0. Okay, so that's easy. It's kind of like an algebra problem. So I want to find out when does this equal 0, because this is how I find critical numbers. I should have written directions. Find the absolute max and min. Okay, so solving this to find out when it equals 0, I would take this to the other side first because I don't like the negative. Okay, and now it's positive, and then if you have a fraction equal to a fraction, you can cross multiply. So if 2x to the 1/3 equals 2, and then I'm going to divide both sides by 2. I'm basically just doing the algebra here to get it by itself. And this means cube root, so you can undo a cube root by cubing, as long as you do it to both sides. So x is going to be 1. So that's a critical number I have to check. Oops, there we go. That's a critical number I have to check. And then I also want to find out when it's undefined. Now, that's not as much like an equation as it is. Remember when we would be looking for vertical asymptotes or holes? And those occurred when anytime you saw a fraction, they occurred when the denominator is 0. So the undefined would, for this equation, only happens when x to the 1/3 equals 0. It'll be undefined. So when does x to the 1/3 equal 0? I don't know, cube it. And that would be when x is 0. So I have two critical numbers. Right? Two critical numbers, x equals 0 and x equals 1. I want to check this graph on the interval from -1 to 3. So sometimes you'll find critical numbers that are outside of the realm. Both of these lie between -1 and 3. But let's say I would have done this work and I would have found an answer of 4. I wouldn't have to include it because I'm only looking from 1 to 3. So sometimes you throw out your critical numbers if they don't land on the interval that we care about. All right, so let's test this out. Remember, I only have to make a table of values. The only place, what's kind of crazy is, even though I don't know what this graph looks like, this graph, I know that the only place max or mins can occur is either x equals 0, x equals 1, or one of my endpoints for a total max or min. So let's do our table. So I'm going to do my x and y table. You can do it vertically or horizontally, whichever way you want. Maybe I'll do it this way because we're kind of used to it. So we want to put the endpoints on. My interval starts at -1 and goes to 3. So I'm definitely testing those two. And then I also got two critical numbers of 0 and 1 that I'm going to test. So these are critical numbers. These are endpoints. Those are the only things we have to test, which is kind of crazy. So make sure when you're plugging these x values in that you plug in to the original equation, not the derivative. We only use the derivative to find critical numbers, so it was kind of like a stepping stone. So now my original equation was this, so I don't have to flip my page over. Okay, so I'm going to plug a -1 in here. I'm going to plug a 0 in. I'm going to plug a 1 in. So we're going to try them all. Let's see here. We got 2 times -1 minus 3 times -1 to the 2/3. All right, so we'll do it once with a -1. We get -5 as an answer. We'll do it again with a 0. Right, just go back up here, change them to zeros. You get 0. I didn't even need to plug that in. Why did I do that? Okay. Then change it to a 1. And you get -1 and a 3. So we're cranking out some numbers here. And then we just have to look at the results and see which one's the very highest point, which one's the very lowest point. That's -0.24. Okay, so now when I look at these, I'm searching for the highest and lowest y values. So here we have, there's our winner for our min. That occurred at an endpoint, not a critical number. And our max, our very highest point, doesn't look high, but that is our max at 0 and 0. So without looking at the graph, I already know the very highest point and the very lowest point on that interval just by checking endpoints and critical numbers. Now to look at the graph, see there's the equation. If I graphed it, it's a crazy looking graph. That's called a cusp, where it comes to a weird point. But is it the highest point from -1 to 3? Yeah, 0, 0 is the highest point. The lowest point, there is a relative min right there. I bet that's a relative min. Anyway, Good times. You're going to do that same process where you find critical numbers. You plug in the endpoints and your critical numbers, and your highest number wins maximum, your lowest number wins min. So that's what you can do in your worksheet. All right, folks, talk to you later.